Wireless personal communications. Stream-based authentication strategy using IoT sensor data in multi-homing aqueous big data network. Non-modified. Abstract. Big data analytics has addressed many places and remote work issues in a subaqueous distributed computing environment. Recently, a new phenomenon is introduced in the data analytics clusters that focused on the multi-homing network connectivity procedures among off-ground multiple nodes of the large-scale on-running wireless industrial applications. In this way, the cluster performs multi-layer cross-connected task processing among various networks simultaneously and performs string-based data block placement over multiple nodes in sequential order. This satisfies the procedure performance of the cluster. However, security remains an open issue in it because of unavailability of inter-network data block processing authorization. In this paper, we propose a stream-based authentication mechanism that specifically addresses security concerns of multi-homing aqueous big data network and present a key authorization infrastructure that perform a proper handling taking among multiple off-ground data nodes before an inter-network data block exchange. The simulation results deficit that our approach increases multi-homing network compatibility and reliability while processing a data block in the subconscious distributed computing environment. Keyword: Big Data, Multi-Homing Wireless Network, Subconscious IoT Data, Internet Security, Interconnected Authentication. Introduction. Big Data Analytics is a phenomenon that performs a large-scale dataset processing in a distributed computing environment. This processing is carried out through some system software applications such as Cloudera, Apache Hadoop, and Mabar. Apache Hadoop is widely used to its open source nature and flexibility of being deployed on the low configuration cluster with a four component. For example, YARN, MemReduce, HDFS, and Hadoop Commons. YARN is a controller that distributes the resources such as memory and computing capacity even on the network node. MemReduce is a programming model that fairly performs the task to distribute the node and then process a large-scale dataset on the cluster. Hadoop distributed file system (HDFS) is a cluster file system that systematically manages datasets and then provides read, write, and execute functions on the cluster, and Hadoop Commons are used for libraries to execute all these demonstrated throughout the cluster. Recently, it is over that Apache Hadoop is connecting multiple clients having different file system besides HDFS through a subconscious multi-homing network that simply the usage of various network application executions at the same time, and for that purpose it requires a separate authorization mechanism. We find several approaches such as Kerberos network layer authorization protocols (KAP) that address single network authentication support. However, we do not find any scheme that processes various network clients through a single authorization procedure as shown in Figure 1. Moreover, due to the underwater data processing, the data chunks are observed with a ratio of low communication bandwidth in the central repository 12. To solve this issue, we propose a multi-homing key exchange authentication protocol MEAP that enables NFF network file system to connect multiple data nodes of various networks with a security and reliability weight communication. The MEAP-enabled client decreases inter-network connectivity overhead and then provide a trusted way among nodes to communicate with each other through a secure umbrella. In this way, we obtain substitute, not use the low communication bandwidth, but acquire a trusted inter-network node to store subaqueous dataset to nearby data node. The main contributions of the proposed scheme are A novel public key encryption strategy to encode the various clients in the multi-homing sub-aqueous packet. A novel proprietary key description strategy and HDFS to decode the trust multi-homing sub-aqueous client. The remaining paper is organized as follows. Section 2 discusses related work. Section 3 briefly explains proposed approach in MEAP. Section 4 deficit experiment environment and evaluate the result for MEAP-enabled client. Finally, Sect 5 shows conclusions and the future research directions. Related work. Kerberos is a long waiting scheme that requires a huge time to interact with network node. Therefore, it was skipped for having a huge session, lagging issue, and latency timeout. 13. The scheme-related HDFS security are divided into two types. For example, delegate tokens and block access tokens. Both of the schemes are compatible with a mode of communication known as privileged and non-privileged client. However, do not incorporate any mechanism to identify incoming requests from a diverse network. KEEP is a single network authentication protocol that authorizes network node to connect with each of the available data node reliability. However, when we incorporate KEP with multiple homing network, it fails to identify clients having contrast IPs than a single network IPs, as the HDFS security features rely on two DT and BAT features. That is why the other scientific contributions, which are non-HDFS, could be added as part of related work here. In order to fill this gap of requirement, we propose an MEAP NFS that enables a novel multi-homing key exchange protocol to authenticate clients from multiple networks and allows them to connect to cluster for processing large-scale datasets in multi-homed distributed environment. Multi-homing key exchange authentication protocol. MEAP works in two stages, such as first, public and private key certification generation, and second, application of certification for MEAP client. At first, the scheme generates public and private key certificate and configured around networks to identify and exchange those certs. In second part, HDFS allows a MAP-enabled client to connect over each file directory and ensure trust as shown in Figure 2. MEAP-enabled multi-homing HDFS cluster. Public and private key certification generation. Name codes generate the public and private key certificates according to access control list ACR of user ACR with right to user and distributed to trusted networks ID for connecting in reliable manner. Table 1. Public key certificate. The steps involved in generating PKC include the product of prime integer p, Diffie-Hellman group, Sophie German prime, random number generation G is primitive root modulo of the integer p and trusted network information network ID that equals to the erroneous totient function. The resultant function rho is swap generation value with public key. Value and generate certification authority CA. The public key can be generated as public key p integer G mode row network ID. Now MIM needs it to incorporate digital signature DS3017 with the public key to generate certificate. The obtained certificate cert public key can be generated as the user ACR of HDFS are then encrypted through generated certificate certpub and generate a message. The formulate message E is obtained as message E. User ACR certpub private key certificate PRKC. The generate of public key certificate involves the same ingredient such as prime integer p and number generated G, but with inverse multiplication modular function WB mode that extracted through a co-prime number obtained through a row M mod P-1, W mod Q-1, G inverse mode P. Finally, a private key. Private key could be generated and reserve the first step for decoding public key. Public key as private key int G mode WWP WG W inverse. Now MIM needs to incorporate digital signature with private key to generate a certificate. The obtained certificate private can be obtained as HDFS gateway descripts the previous message E that also involves a network information, network ID through a certificate of validation, certificate private. The final descripted message can be described as message D equal user ACL cert preview network D. Application of public and private certificates over MIP client. The second phase requires identifies to know whether the incoming connecting is coming from local network, request local network, or remote network, request remote network through cluster port map configuration. After that, the client information is passed through gateway as such as local gateway and the remote gateway. The message E is described using client session. Having network ID and user information write to user through key tab. The key tab is a set of principles to allocate HDFS namespace and assign session, client session over HDFS directory, mount point with a lag of nodes, data nodes, and illustrated in figure 3. We've enabled the authentication mechanism of multi-home HDFS cluster. Experiment evaluation. In this section, we evaluate the MEAP approaches over cluster configuration as seen from Table 2. Environment. The cluster configuration consists of Intel Xenon processor with 8 CPU, 32 GB memory and storage devices, 1 TB hard disk drive. In addition to that, we use Intel Core i5 with 4 core 6 GB memory and storage device, i.e. 1 TB hard disk drive. We install 5 virtual machines having VirtualBox 5016 as seen as Table 3. Experiment dataset. MIP evaluation dataset consists of first 25 aqueous IoT data blocks, 64 MB having total length of 1.86 GB sensory data size. Experimental results. The evaluation carried out for performance measure are local network client access and the multi-homing network client access. Local network client access. In order to observe the local client connectivity, we executed lookup analysis 20 to 24 over the 3 types of local network connections, i.e. local MIP NFS enabled client, local privileged client, and the local unprivileged client. We observed that the above mentioned client consists of 500 HDFS NFS gateway instances and evaluated that local MIP NFS enabled client assumes 13 averagely over connecting to NFS gateway. In the same way, we observed that local privileged client consumes 19 averagely when requesting connection to NFS gateway. Similarly, we observed that local unprivileged client consumes 25 averagely established connection to NFS gateway. The MIP enabled client is 48. That 19 effective than local privilege and then 94.5% effective than local unprivileged client over established connection to NFS gateway as shown in figure 4. Multi-homing network client access. In the same way, we also evaluate the efficiency of remote network client connectivity, again using remote network lookup analysis onto 3 types of connection, i.e. remote MIP NFS-enabled client, remote privileged client, remote unprivileged client. MIPS sets HDFS threshold of remote network connections on 500 instances. We observed that remote MIPS NFS enables client consumes 19 average for established connection with NFS gateway. Similarly, we evaluate the remote privileged client consumes 28 averagely over established connection to NFS gateway. In the same way, we find the remote unprivileged client consumes 32 averagely while establishing connection with gateway. Remote MIB enabled client 39.43% efficient than remote privileged and then 73.41 effective than remote unprivileged client while establishing connection to NFS gateway as shown in figure 5. Conclusion. This paper proposed a novel multi-homing key exchange authorization protocol MEAP onto the sub-aqueous IoT sensors HDFS repository. The proposed approach introduces compatible solutions to interact multi-homing client with Hadoop network underwater and find the client connectivity reliable by avoiding the available low communication bandwidth. The experimentation is carried out over 3 connections with respect to local and multi-homing networks and then proven the worth of proposed scheme in a sub-aqueous distributed computing environment of Hadoop cluster. In future, we focus to incorporate other resistance mediums of sub-aqueous environment in multi-homing Hadoop cluster.